Alrighty, so there's one last thing you've got to know in terms of the normal distribution and the standard deviation. As I think the third thing you need to know is called standard scores, and we more commonly call them z-scores. So that two different names, they mean exactly the same thing. So a standard score or a z-score tells you how many standard deviations, and that's the thing we saw in that graph before, you are from the mean or the center of the data. So here's a quick formula for you to use. You will have to use this formula. You can calculate z-scores on your calculator, but you will use this formula, so you'll need to know it. The standard score, or the z-score, is whatever your piece of data is that you're looking at, minus the mean divided by the standard deviation. And here it is in mathematical terms again. The z-score equals your piece of data, take away the mean divided by the standard deviation. So that's an S, if you couldn't tell. They're the same formula. It's just a sort of a basic way to write it and the mathematical way to write it. So here's an example. If you're given, you're looking at the number 62 and you're told in this same set of data the mean is 50 and the standard deviation is 6, we can just put that in the formula and work out where this piece of data is, 62, according to this normal distribution. So our z-score, our amount of standard deviations from the middle, is x minus the mean divided by the standard deviation. So it's 62, that's the piece of data we're looking at, minus the mean divided by the standard deviation. So in this case, our z-score was 2. Now that means that we are 2 standard deviations above the median or the centre. Now if I quickly just pull out my old page that we were looking at just a minute ago. So if you look for the 2 standard deviations, that's this person that got, we saw 62, they are sitting 2 standard deviations above the middle. So this is the curve we're looking at. They're 2 standard deviations above the mean. So actually, they're in the top 2.5% of people, or they're better than 97.5% of people. So this person scored quite well. This person who's got 62 is at quite a high point. So if this were test marks, that student's done really well, like in the top 2.5% of students. So we could do this calculation for a bunch of different results. So say the mean's 50. If someone got just below that, then they're going to be a negative amount of standard deviation, so they're going to be in the minus direction. I'll show you a few more examples. So here's a sort of a worded example. The heights of a group of young women have a mean of 160 centimetres and a standard deviation of 8 centimetres. Determine the standard score, or the z-score, of a woman who is, and there's 4 things that we're going to do together. So we're going to do these 4 together. If the woman was 152 centimetres tall, we can already see that she's less than the average, less than that mean. So the answer we're looking for is going to be a negative answer because she's beneath the mean, underneath the mean. So she's not quite 1 standard deviation below. In fact, it looks like maybe she's exactly. So 152 centimetres, we can see, just by looking at it and doing no maths, that if the average was 160 and 1 standard deviation is 8, if I take off 160 minus 8, I'm going to get 152. So I can actually see that she's 1 standard deviation below. So I'm going to expect to get an answer of -1 for my z-score, which means 1 standard deviation below. So let's quickly check that. The z-score equals my data, so 152, minus the mean, 160, divided by the standard deviation, which is 8. So 152 minus 160 divided by 8. So we were right, it is 1 below. And then we can do the same process for each one. This one's 144, you can see that's going to be under the mean, so we're expecting a negative answer. 150, that's still under the mean, we're expecting a negative answer. And 170, that's above the mean, so we're expecting a positive answer. We're expecting to be above the mean. It's kind of just a quick self-check. So let's do a few together. I've written out the rule again. Z equals x minus x mean divided by s. Excuse me. Then we've got 144 is our piece of data, our x, the thing we're using, minus the mean divided by the standard deviation. So that equaled -2. That -2 tells us that we are 2 standard deviations below the mean, or the average, or the middle. We are 2 standard deviations below the middle. Let's try another example, and we're expecting this one to be below as well, because 150 centimetres is less than 160. 150 is our data, take away 160, which is our mean, divided by 8, that's our standard deviation. So our answer was -10 on 8, and you'll notice here that instead of getting a whole number like -1 or -2, suddenly we've got this number which is -1.25. That's still fine, it's still correct, but it just means that we can't use we can't get extra information from this property, the properties of this that we saw before. So it doesn't tell us much if we didn't get an exact -1, -2, -3, or 1, 2, or 3. It doesn't tell us any extra information like this does, but it still does tell us that someone who got a score of 100, or someone who was 150 centimeters tall was 1.2 standard deviations below what the average person's height was. So the average person's height was 160. A final example, 170, we're expecting this to be above the mean. So again, my piece of data, 170 minus the mean divided by the standard deviation is 10 divided by 8, which was 1.25. So if you can't do that manually, just put it in your calculator. It will tell you it's 1.25. So that's saying that someone who is 170 centimeters tall, this young woman, she is higher than the average person who's at 160. She's 1.25 standard deviations above what the mean or the average person would get. So again, we can't use this table of values to tell us anything useful because 1.25 is not a clear statistic or a clear percentage, but we do have the information about 1 above, 2 above, 3 above, 1 below, 2 below, 3 below. We'll do many more of them in class because they're going to keep coming up in SACs, they're going to keep coming up in exams. Like, I promise you that there'll be at least one, probably on each of your exams at the end of the year, if not 2. They're a pretty common kind of question for us to practice and get good at.